All right, it's recording. So today's lessons, we're going to work on 8G, 8H. Remember, in the planner, we're not doing the first half. That's statistics. We're working on probability only. So it's 8G, 8H, 8I, 8J. There's only 4 exercises that we're working on probability. Okay? Let's fill in some notes so that you get used to the terminology. These terminologies we use all the way up until year 12. So you do need to understand what they mean when we ask you those questions. First one, when they say sample space, the definition of sample space is the set of possible outcomes. But in case you don't understand outcomes, write in results of an experiment. Now, when we say experiment, rolling a dice is an experiment. Flipping a coin is an experiment. Spinning a spinner, like a spinner wheel, is also an experiment. It's essentially the act of testing something. For example, if you went gambling and you played a particular game, that's an experiment because each round is a test, right? So, what is a sample space? The sample space is all the possible outcomes. So if I was to roll a dice, what are the possible outcomes or results I can get when I roll a dice? Can I please have Yi Chen? When you roll a dice, what can you possibly get? 1, 2, 3, 4, 5, and 6. That's called a sample space. So a sample space of rolling a dice. If I asked you, what's the sample space of flipping a coin? If you flip a coin, what would the sample space be? Heads and tails. Okay, so you either get heads or you get tails. So sample space literally just means what are the possible outcomes you're going to get when you try out this experiment. Yeah? Complement. Now, complement can get a bit confusing. It's different to complement. Complement is spelled with an I. So if you say compliment, that's me saying something nice to you, praising you. Complement means to match, right? Now, is often written with a dash. Complement of E is written as, and we normally write capital E with a dash. That means complement of E. Now, when we say complement of E, what does that mean? It just means that the group has all outcomes that is not part of E. Okay, so the question is, what is E? Well, E is a group of outcomes. So here's an example, just so you understand. Let's say we roll a dice, a regular dice. You told me all the possible outcomes. The sample space were 1, 2, 3, 4, 5, and 6. When we use a capital letter, that's called a set. It's like a group. I can say E stands for all the numbers that are even. Now, what numbers would I have? If I rolled a dice, which numbers or outcomes would be even? What are my even outcomes here? 2, 4, 6. Very good, Hamza. 2, 4, and 6. So when I say E represents the groups of 2, 4, and 6 that are my possible outcomes, then when you write E dash or E complement, that means in this group, it should be everything that is not part of E. That's what I mean here. So when I say has all outcomes that is not part of E, that line that I'm saying here, all outcomes that is not part of E, then what is not part of E? What are the leftover outcomes I could get? 1, 3, 5. Very good. You're on the ball. So 1, 3, 5 is what we call complement because it means it's not. 1, 3, and 5 is the leftover outcomes of all the possible outcomes that you can have. Since E takes 2, 4, and 6, which is here, this is 2, 4, and 6. E has 2, 4, and 6. So then E complement means it's everything but 2, 4, and 6. So it must be 1, 3, and 5. Okay, so obviously if you put E and E dash together, you have everything. That's the idea. So they complement each other. Yeah? It's like if one was 70%, the other one must be 30%. Together it's 100%. That's the idea. Yeah? So complement is a bit tricky for the first time if you've never seen it before. The complement of rolling the number 3 with a dice is 3 dash means not getting a 3. Okay, so if I said, what's the complement of rolling a 3? What I'm saying is, what are the possible outcomes if I don't get a 3? Okay, because not part of getting a 3. So all the possible things of not getting a 3, well, I can get a 1, 2, 4, 5, and a 6. That's what it means when they say complement of rolling the number 3. Okay, so complement of rolling the number 3. And that would mean that the numbers that can come out is 1, 2, 4, 5, and 6. If you notice that I'm doing these curly brackets, in probability, that's actually called curly brackets. It's all the proper name's called braces. Okay, you can call it curly brackets or braces, but you use them to collect numbers or outcomes in probability. So that's why I'm doing that curly brackets. So the curly brackets kind of look like this. It goes 1 little hump and then down. So that's my curly brackets. But when I do it fast, I'm just gonna match it like that. That's what we use to list a set of numbers. Okay, we don't use an open bracket. We don't use a closed bracket. We use curly brackets. Whoops. Okay, it's curly brackets. All right. Experiment I've explained before. It's a situation involving chance. So anything could be a chance as long as you're involving yourself in something that involves a chance. Trial is different to an experiment. Experiment is the thing that you do. But trial is how many times you do it. So if I rolled a dice, I can roll it 3 times. That's a trial. So I had 3 trials. I can roll it 5 times. That's 5 trials. You can flip a coin once. You can flip a coin twice. You can flip it 3 times. The number of times you flip it is the trial. But the experiment is flipping a coin. Okay, how many times you flip it, that's called the trial. Okay, so here is a process which can be repeated in the same manner to produce an outcome. And we're coming towards the end of the theory here. Probability. Most of you have already an intuitive understanding of probability. It is the chance of and now this is a proper name for it. It's called an event. Okay, so when I said find the chances of rolling a 3, 3 is the event. When I flip a coin, I say, what's the chance of getting tails? Getting tails is the event. If I said, what's the chances of picking someone in this room that has a parent that works in the Air Force? That, working in the Air Force, parent working in the Air Force is the event. Okay, so we call that an event. It's what you're looking for. Okay, so the chance of whatever the experiment is, that is called the event. So notice the language that we use when we do probability. Instead of writing probability, mathematicians were too lazy. So we use the capital P, R, and people should know that that means probability of. So if I wanted to say, what's the chances of picking someone in this room whose parent works in the Air Force, I would write something like PR of parent working in Air Force. But can you see how this is really long? So as mathematicians, we don't like doing that. That's why we use sets or capital letters. So if I said, let P, let's not do P, let's do T for Tran. Let T equal to parent working in the Air Force. Then when you say PR of T, that's much shorter. And that's how mathematicians do it. We define a variable. We use a capital letter to denote a set. And then PR means find the probability of T. But T means parent working in the Air Force. So in this one little notation, it tells people what we want them to find. Now, you might not be used to using these notations yet, but at least try to read them. So when you see them used in your textbook, that's what they're trying to get you to understand. Okay, so just learning how to read, you're not necessarily learning how to use. But if you can practice it in your exercise books as you're answering the questions, using the notations is key. Because I'm still teaching my year 11s how to use these notations properly. Okay, because that's what we do. We shortcut things, but you have to define. You have to know what PR stands for. You have to know, use the brackets or curly brackets. They all matter. Okay, it's the convention. So in this particular scenario here, for example, if I was rolling a dice, the chances of rolling a 2 can be written as, who wants to have a go? Instead of saying chance of rolling a 2, instead of writing in words, how would you write it as a notation here? What's the chance of rolling a 2? How would you say that? Yeah. Assuming that they know the scenario is rolling a dice, then that means chances of rolling a 2. Okay? But if you didn't give them the scenario, then that wouldn't mean anything. So this is what we would do as mathematicians. We write PR for find the probability or the chances of. The event is rolling a 2. So if you want to be more specific, you can write rolling a 2. If you want to use a letter to represent that, you could do capital R equals rolling a 2. And there'll be PR of R. Yeah, so doing PR of 2 is probably what you'll see in your textbooks. Your textbooks won't go too deep with the set notations. Okay? All right, let's do some examples now. So that's the theory bit. We're going to do some examples so that you can see how G and H sort of flow with each other. Let's do flipping a coin. Here we go. So our experiment is flipping a coin. Let's list the sample space. Now remember, when you list the sample space, which bracket do you use again? Curly brackets. So use the curly brackets. And what's my sample space when you're flipping a coin? Heads and tails. Very good. So write H, comma, T. Because if you don't put a comma, people think that HT are together. So by putting a comma, you're saying that's the first outcome. And then here's your second outcome. So you can get H or you can get T. Now, it says the probability of flipping tails is. Now, I want you to write this with the notation I just taught you. How do you write probability of flipping tails as a set notation? Yes, Fitzroy. Beautiful. That's it. PR, and I love the fact that you said brackets. A lot of students in my year 11 just write that without the brackets. The brackets do matter because we don't know where the event starts. So if you don't put in the brackets, people don't understand. So it's fantastic that you said use the brackets. You have to have brackets there because inside the brackets is the event. In this case, I've already said sample space is H or T. So what I'm asking now is probability of getting tails. Now, how do you find probability again? How many options are there that you can get? There are 2 possible options, but if you want to get T, how many T's can you see? 1. So you only have 1 out of the 2 options that are available. So your chances are a 50-50 or half a chance. Okay, so you've got 50% chance, or you can think of it as 1 out of 2 chance. What about the next line? Who wants to have a go with this one? Probability of rolling a complement of getting tails. How would you write this? Yes, Carissa. I know the answer is 1 over 2, but I want to know how to write the notation. Very good. But I don't just write T dash. What am I missing? PR. We need a capital P. R. What else am I missing? Brackets. Very good. Brackets very important. That's the proper way. So I don't want to just see your answers half. I don't want to see T dash. I want to see this entire line. Because that line is the notation you're learning. You're learning the language of probability. So that means chances of getting not a tail and chances of not getting a tail is the same thing as saying chance of getting heads. So obviously there's only 1 H out of 2 options. That's why it's 1 out of 2. Okay? So just getting used to that language. Let's try an example that would be similar to your textbook. Let's have a look at this one. Example 1. Example 1 now says the letters of the word prince, P-R-I-N-C-E, which is written in this block here, are written onto 6 equal sized cards and they're chosen at random. Okay, you're choosing them at random. List the sample space. Same thing again, when you list the sample space, what kind of brackets must you use? Curly brackets. Very good, Hamza. Curly brackets. So what's inside my sample space? How many possible outcomes can I get? 6. But you don't just write the number 6, you write all the possible outcomes. You can get A, you get 1 P, you get 1 R, 1 I, 1 N, 1 C, or 1 E. So you have 6 cards and you're going to choose one at random. So what are the possible cards can you pick? You can pick a P card, R card, I card, N card, C card, or an E card. Now notice I used the notation for you already. I said here, find PR, so probability of getting the letter N if it's chosen. So imagine if I close my eyes, I have 6 cards to choose from. What's the chances that I pick the card with the letter N on it? You would say 1 out of 6. Very good, because there's only one N. One N. So PR of getting an N is equal to one option out of the 6 possible outcomes. Let's go on the next one. Can you see how I'm writing let V equals chance of getting a vowel? So instead of writing the event as PR of chance of getting a vowel, it's too long. So in mathematics, we define it. We use a capital letter to represent that group. We say V means chance of getting a vowel. So when I say find PR of V, reading it actually means probability of getting a vowel. Now what are my vowels again? That's it. A, E, I, O, U. Those are my vowels. So how many vowels are there in my 6 options? How many vowels can you see? 2. There's I, that's a vowel, and E is a vowel. So if I answer the question, probability of getting a vowel is equal to, out of 6 options, there are 2 vowels. It's 2 out of 6, but you never write your answers just 2 out of 6. You've learned fractions now. What's 2 out of 6? 1/3. You got to simplify it. At year 11, you lose a mark. If my students leave it as 2/6, they lose a mark. They have to actually put it down to 1/3. You guys, I can give you a warning. Yeah. So here, common factor is 2. They both can be halved. So you'd say it's a 1/3 chance of getting a vowel. So if you had to choose randomly, what's the chance of you picking a vowel? You've got a 1 out of 3 chance of picking a vowel. What about the next one? Let's pick someone. Let's go with Jacob. Last one, D. PR of V dash. Now V means to get a vowel. What does V dash mean? To not get a vowel. So if you're not getting a vowel, remember vowel is getting an I or an E. So what's not a vowel? Very good. So you can either get P, R, N, C. Those are my not vowels. Those are the complements of getting a vowel. So that's what the dash means. Not getting a vowel. So what's my probability then? Fitzroy. Beautiful. 4 out of 6. But we don't leave our answers 4 out of 6. It should be 2/3. Very good. Common factor of 2. So far, so good. So I taught you sample space. I taught you the language, experiment, event, and how to provide probability. You're feeling confident? Flip over to the page. Flip over the page, and let's see if you can answer some of these questions now. Let's put this now. So I'm going to help you along with this one because this is a 2 experiment problem. Let's have a think about the problem. Before you only had picking a card. What if I got you to do 2 things simultaneously? What if I asked you, I want you to spin the spinner. It has 1, 2, and 3. So spin the spinner, and after you spun it, I want you to then choose a card out of A, T, H, S. So the card has 4 letters. You have to spin the number, and then pick a letter. Okay, so there are 2 things now. Rather than just flipping a coin, rather than just rolling a dice, this time you're spinning and picking a card. So, if I asked you the sample space, it gets a bit tricky here. You can think of it as like this. These are your possible outcomes. You could have picked a 1 when you span it. You could have got a 1, and then you picked a letter A. But you could have got 1, but picked the letter T. You could also have picked a 1 and picked the letter H, but you might have spun a 1 again, but picked the letter S. That's 4 options there. What's the total number of options? Just looking at it mathematically, can anyone see the pattern? What's the total number of possibilities? So you could have got spun a 1, chose an A, spun a 1, chose a T, spun a 1, chose a H, spun a 1, chose an S. What's the total number of possibilities? 12. Very good. Who said that? Good. Okay, because each one has an ATHS. You can get a 1 and an ATHS, ATHS, ATHS. It means there are 3 options times by 4 options. So 4 plus 4 plus 4 is 12, or you can think about it as 3 times 4 gives you 12. So there should be 12 possibilities. Now you can write it the way I just did. You can write 2A, 2T, 2H, 2S, 3A, 3T, 3H, 3S. So some of my year 11 still do this. That's fine. It's intuitive. But we like to give you a tool so that you don't always have to use intuition to get there. One of the tools that you learn in probability is called a two-way table or Carnot map. Two-way tables only work for 2 events. If you have 3 or more events, that won't work. Your intuition would probably be better. But in this case here, this is how a two-way table works. I've already set it up for you. The row represents the first event. So you spun the wheel. The column represents picking a card. Now what's nice is once you put it into the grid, you can see the missing spaces are all the possible outcomes. You could have got a 1 and an A. So it would have been 1A. You could have got a 1 and a T. So you could have spun a 1 and then chose a T. So you can see it's much more organized. And no matter how I do it, if I said roll a dice and flip a coin, you should be able to use a two-way table and figure out the possibilities. Because I could have said flip a coin twice and then tell me rolling a dice, what are the total chances? Yeah, so this is a good way to organize your information. So here you got 1H, 1S, 2A, 2T, 2H, 2S, 3A, 3T, 3H, 3S. And you can quickly see it's 3 times 4. That's why there are 12 possible options there. So when we work out probability, we know it's out of 12. Here we go. List the sample space, which we already did. Curly brackets. 1A, 1T, 1H, 1S, 2A, 2T, 2H, 2S. Oh my God, this is a long one. 3A, 3T, 3H, 3S. You can shorten that if you already understand what I'm talking about. Okay, but the idea is how do you get all the possible outcomes? Notice where I put the commas? I put the commas because now I'm saying 1A becomes one possible option. 1T is one possible option. If you don't put the commas, it gets confusing. Is it 1 and then H and then 2 and then A? It's better to make sure to have the commas there. Okay? Once you've got the table out, it's now much easier to solve the problem. If you don't have the sample space, it does make it a bit harder to solve the problem. So let's try the first problem. For those who are ready, find the probability of spinning a 2 and choosing the letter S. See, if I asked you that initially and I didn't show you this grid, some of you might have been able to answer it and some of you can't. But most of you now should be able to look at the table and tell me what's the chances, the probability of getting a 2 and the letter S. We already know it's out of 12 because there's 12 options. How many 2s and S's can you get? 1. It's right here. That's the only one where you can get a 2 and you get an S. So there's only one option out of your 12. So your chances, it's 1 out of 12. But can you see how I'm guiding you? If I hadn't shown you the table, I hadn't explained how to list all the options out, some of you might be able to answer and some of you might have given up because it's 2 steps rather than doing 1 step. So this is called a 2-step experiment. Yeah? Let's try the next one. Find the probability of spinning an odd number. So I'm trying to make it a bit harder. Find the probability of spinning an odd number and then choosing the letter H. So I'm saying find the probability of getting an odd and the letter H. Remember there's 12 options. It's out of 12. Now let's look at the table again. Count. How many of them are odd? And then how many times are you going to get a H? So you want a H and an odd. 2. Let's have a look. We've got a 3 and a H. 3 is odd. But H is only in this row here. So out of these 3, 2 can't be it. It has to be 1H. So my answer, yes, it is 2. It's 2 out of 12, but you never leave your answers 2 out of 12.
1/6.
1/6. Beautiful, Xavier. How's that feel today? That there is a typical problem if I wanted to extend you and I didn't guide you just then, that would have stumped some of you. So hopefully you learned something compared to when we did the readiness task. Some of the questions I put were this. So how many were you able to figure out the possible options and then figure out the probability or read the notation? Hopefully today you learned a couple of things. Sample space, notation, and how to actually utilize a two-way table. Okay, so this Y8H, it should be 2 of them merged together to allow you to see how they all combine together. If you want to start off sort of easy, then AG. If you go to 8H, it gets more something like this. Okay, so AG is a bit more simpler, and then 8H gets more complicated with 2 events. Cool? So we finish off there. You got 25 minutes now. That's your time. And remember, next week I'll be doing I and the J. We finish it off, and we'll finish off with an exit ticket before your reports. So make sure that update. If you haven't done it, this is your time as well to finish off your checkpoints, reflection. If you didn't have enough time before, make sure to do your reflections. Okay? You want to stop the video?